Class, we will be talking about vertical compression and vertical stretch. Vertical compression and vertical stretch. Okay? You need to listen carefully to what I have to say. Okay? So f of x is equal to, and I'm going to use the parent function for the quadratic function family. Okay? I'm just going to show you a demonstration. And we are going to make a very important observation. Okay? A very important observation. And I want you to pay close attention. Okay? This is our parent function, the one at the top. Okay? Alright, I'm going to type a 2 here. Okay? I'm going to type a 3 here. I'm going to type a 4 here. And I'm going to type a 5 here. Now notice what I've done. I applied numbers to the outside of the original function. Let me make this clear. Right, let me use red. Okay. Alright, so I have applied numbers to the outside of the original function. Now notice as the number on the outside increases, the original graph, which is the black graph, this graph, the original graph gets thinner and thinner and thinner. So as the value on the outside of the original function increases, the original graph gets thinner and thinner and thinner. This is an example of a vertical stretch. It's an example of a vertical stretch. I'm going to tell you why we say vertical, and I'm going to say why I say it is a stretch. Okay? Let's talk about the adjective vertical. Why is it called a vertical stretch? The reason we use the adjective vertical is, as I said in previous videos, once you apply something to the outside of the function, is going to lead to a vertical change. Alright? So that has been the common thread throughout all of my presentations. Once something is applied to the outside of the parent function, there is going to be a vertical change. Okay? So that's the reason we use the word vertical. Now, stretch. How does the word stretch fit into this presentation? Let me explain. Picture an elastic band. Yes? An elastic band. So let's say that the original graph is an elastic band. Yes? Right? Now, if I should pull on the end, sorry, let me do that over, okay? If I should pull, so we are pretending that the graph is an elastic band, okay, or a rubber band, okay? So if I pull on the rubber band in this direction and in this direction, yes, it would lead to a stretch, right? I would be stretching the elastic band, all right? And it would resemble something like what I have. If I keep on stretching it, I'm going to have something looking like this, yes? Where it gets narrow. So as I stretch the rubber band, it's getting narrow, yes? The space in between is getting narrow, yes? All right. Sorry for the poor diagram, okay? But it's like as you pull on the ends, of the rubber band, yes, it gets narrow, all right? It gets narrow, all right? But what you would be doing is you would be stretching the rubber band, all right? And as you stretch it, it gets narrow. The space in between gets narrow, okay? So the reason we describe the change of this graph as a vertical stretch is that as you increase the number on the outside of the parent function, the new graph has the appearance of an elastic band that you would stretch vertically by pulling on the ends upwards. Okay. So I hope that this analogy will help you to understand why this change in the graph is called a vertical stretch. Okay. All right, let's see what happens when I do something else. All right. So this is going to be a half this is 1 over 2, right? And this is going to be a third, okay? And this is going to be 1/4. And let me make this one 1/5. It's 1/5. Okay. All right. All right. Notice our original graph. Let me indicate to you where it is. Our original graph is this graph right here. All right. The black graph is our original graph, which corresponds. I apologize for that interruption. Okay. All right. So this graph is our original graph. Yes? And it corresponds to the parent function. Yes? Now notice when the number on the outside is a fraction which is between 0 and 1, the graph gets flatter. Yes, the graph gets flatter. Yes, it gets.
Mr. Broadhurst, please call 4201. Mr. Broadhurst, please call 4201.
I apologize again for that interruption. Okay, so when the fraction that is on the outside of the parent function, when the number is outside of the parent function and it's a fraction between 0 and 1, the graph is going to get flat, right? It's going to get flat. And as the fraction decreases in value, it gets flatter and flatter and flatter. Okay? Get that? Now, the change that took place in this graph is referred to as a vertical compression. A vertical compression. Yes? Now, let me say why the word compression and vertical is being used. Okay? Let me start with the easiest part, compression. The reason the change in this graph is referred to as a compression is the appearance of the new graph or the new graphs resembles a situation where someone pressed down on the original graph. So compress means to press down on something, right? So the new graph, the new graphs that we have here, all right, that come from this graph resembles a process where someone would press down on the original graph, all right, to give you the new graphs, all right? So I am using this analogy to help you to understand why the terminology compression is being used. Now, why is the word vertical used in this case? Why is it a vertical compression? Notice I said that the process resembles someone pressing down on the original graph. But notice the direction of the arrows. Yes, these are moving in a vertical direction. Yes, vertical direction. So our change is taking place in a vertical direction. Yes, so that's the reason the change is called a vertical compression. The other reason it is called a vertical compression is, as I said to you repeatedly, whenever we apply something to the outside of the parent function, there's going to be a vertical change. Yes? So we applied fractions to the outside of the parent function and it led to a vertical change. But the vertical change is called a vertical compression. Okay? I hope that this video has been helpful. I hope that this video has been helpful, and I'm asking you to re-watch this video and remember the key points I made, okay? In my next presentation, I'm going to create a video on horizontal compression and horizontal stretch. Have a good day, class.